at CloudVPS. We're an IaaS company for the last 10 years. So we have a lot of experience with different platforms. For example, Xen, Hyper-V, and since 4 years we also run a public OpenStack. In these years we've gathered a lot of experience in IaaS, providing IaaS for our customers. And we also gathered a bunch of instances and a lot of memory and storage capacity. So to give you an example, our current OpenStack platform is over 100 nodes, and we have more than a petabyte of storage for instances and volumes. So the journey to a new OpenStack. First question is why? Why a new OpenStack? Why not upgrade the current one? We were very early with deploying the OpenStack, and code back then was under development. We had to make a lot of changes in the code to even get it working. We also made a lot of design choices that were, well, maybe not the best choice if you look at scalability. Besides that, upgrading was not a topic in OpenStack back then. Main focus was to get it running from the OpenStack perspective as well. So that's one of the main reason. Also, if we would want to upgrade our current OpenStack, we could have done it, but it would have cost a lot of downtime for our customers. It probably would have meant the entire cloud would go down for several hours, and that's, yeah, well, we would like to keep the downtime as low as possible, or at least segment it, but there was no option to do so. So we started looking at a new OpenStack, and to do so, we started with gathering requirements. What do we need? What have we learned from our current OpenStack? What have we learned from IaaS? One of the main things is automation of your deployment of the OpenStack environment is a key to run a big cloud. It is very important to have the scalability to add new nodes, to make it as fast as possible, and have to not have a lot of work on that. So that was one of the things. Also, we would now need a cloud that is upgradable. The code of OpenStack is ready for it, so we wanted a new OpenStack, but we also wanted to be able to upgrade it in 6 months from now or a year from now. We also have seen in the past that about 25% of the instances we host are part of an HA setup. So one instance can fail, but the service is still running. Which means 75% is still not part of an HA setup. So they are all pets on our platform, and well, we need our customers to move to a HA setup, but they don't always do that. So that was a lesson learned from our current OpenStack. We also wanted to be upfront, innovative with the new platform. So we were also looking for a vendor that is actually helping us with that, being upfront, having the new features, and innovate as much as possible. So we started with the software vendor selection. It was a cool path. We had some requirements ready, like the upgradability was one. Also, the vendor had to be well known in OpenStack, had to also contribute to the OpenStack code. But maybe most important is we were looking for a partnership, not a vendor, but we were really looking for a partnership. Because we have a lot of OpenStack knowledge in-house, we already have a platform, so it was not new. We didn't need to get to know OpenStack. We really only needed to know the new version. So we actually chose for Mirantis. They are, yeah, OpenStack is their core product, and yeah, we've been able to build a stable partner relationship with them. And then there was the hardware vendor selection. There was, for me, it was an easy choice. We wanted to have a reliable brand that has good support, good contact to support. So RMA procedures are good in place. That was one of the most important features. And we also wanted to have state-of-the-art and proven technology combined. So we actually chose for Dell, and after that we started combining those two with checking if they support each other, if Dell supports the Mirantis OpenStack, and if OpenStack supports the hardware we selected, and that worked fine. So after that it was ordering hardware and racking and stacking. In the racking and stacking we also decided to automate everything. So we made a rack design and made it so simple that there was no way to make errors, or there were no questions anymore of how to connect stuff. Everything was in place and it was only one way to connect it. After that we were very lazy, so we're trying to automate every deployment we have, and we even automated the configuration of the BIOS, the iDRAC, and stuff like that. So it also gives us an advantage because it's now consistent. All nodes are the same. There's no surprises anymore. Every configuration is done right. So after we deployed the hardware, we let it spin for a while before we invited Mirantis over. We had a specialist of Mirantis to deploy their beta of the Mirantis certified cloud platform. And while he was there, he flew in and he had a hotel, so we abused him as much as possible. We stayed until late and let him do all the work and show us all the stuff we have. So, but the fun part was, I think it was halfway the first day. When he started, he said, "Well, I'm not sure if we're going to make it in those 3 days because the code is still beta and well, there's a lot of work to do." So when it was 12 o'clock the first day, he said, "Wow, we're already deploying OpenStack. I thought we would have just been at the point of deploying the operating system, but we're already deploying OpenStack. This is going really fast." So with that, after 2 days, we already had a working OpenStack cloud on all of our hardware, and we could start on trying even to break it or to see, to test our use cases on top of it. In that process, we found out that the network was still under development. We had some scalability wishes to start with, but we also had some customer use cases with floating IPs and high available load balancers, and that was not working as expected, to say the least. So we decided to throw it all overboard and redo the network design and start with OpenControl. So why did we go for OpenControl? Well, the main part was the features that were missing, but also the scalability we had in mind made us decide to go with OpenControl. OpenControl is a software-defined network from Juniper, and well, we couldn't only just install a different piece of software. We also had to install routers in our network. We also had to change from stretched VLANs to routed fabric, and well, it was a major change, but that's what we did the book for. So then about storage. What is important in storage? Well, we think it's important to have it reliable. It has to be there always. So even if a rack fails, we would like it to still be available. We also needed it to be able to offer the high available instances, because, as I mentioned earlier, a lot of our instances are still pets, or our customers are still having instances that are not part of an HA setup. So we wanted a storage platform where we could rely on and where we could make the instances start on a different compute node. It's a bit different from a OpenStack deployment that you see a lot, but yeah, we wanted to do it like this anyway. We also made a slight design change to have our storage not stretched over different data centers. We have 2 data centers, and well, we wanted to be able to rely on those data centers. So we have them split in availability zones, and if one of those availability zones somehow fails, we wanted to have the assurance that the other one is still available. So that if you build an HA cluster, you could rely on an availability zone to be there, even if storage fails. So we chose for Ceph. We're making 3 copies. We're making the copies rack aware, and so that if a rack fails, the cluster still survives, and we could offer that high availability to the instances. After that, we also had to add a component to be able to have the high available instances and to have the instances restored when the compute node fails. So we added Mazakari to the Mirantis setup, and well, everyone thought it was a strange choice, because everyone expects the customers to solve the high available problems, but as we've seen, not all do. So, you're looking at the legs of our data center hero. He's walking to our data center to rack and stack the servers. This was the part where we started deploying the production platform. We already did deployment once, so yeah, this one had to go smooth, and it was smooth. We provided the Ubuntu with a product Maas from Canonical. After that, we deployed the Mirantis OpenStack on top with SaltStack, and then everything worked. We had a proper preparation, and all went fine. So after that, now what? What are we going to do? First thing we did is we sent out accounts to every engineer we could possibly find in the organization to help us with testing the new cloud. So 85 of our co-workers got working, got on the new platform, spawn up instances, work with heat, did a lot of awesome testing. Also found some small bugs related to deleting networks and minor stuff. But we could fix that before we started our pilot. We started our pilot with a select group of customers. And some of those customers were so excited they already decided to go live with their websites before we even released the platform to the rest of the world. And then we had our go live, and that was in June, halfway June. So from that moment on, everyone could order an account on our public OpenStack. So then we come to the part of the roadmap. We already have load balancing as a service in our cloud. It's highly redundant. It's easy to use, but it's not. It doesn't have servers for encryption, so you cannot add a certificate to it. That's a thing we're working on to add. We also are continuously working on extending our images, the images we support. We now have a couple of images with standard Ubuntu, standard CentOS, all major Linux distributions are there. But we're adding images with, for example, Docker installed, or maybe even a control panel, or MySQL. That kind of images you can expect from us. And we're continuously working on extending our knowledge base, even have some heat examples and stuff like that. And one of the, I think, most exciting project we're going to do is we're going to also sell traditional VPSs on our OpenStack platform. We are an IaaS provider, and we sell VPSs for a long time now. And we want to continue in having one platform where we can sell OpenStack projects, but also have the ability to deliver single instances with specific needs for customers. And because we already have the high availability or the restart of an instance, that's that's a small step technically. And after that, with our partner, or maybe not after that, but on our roadmap is also to extend to a European cloud. We would like to add availability zones. We're going to add availability zones and regions in, for example, Germany or France or the UK. So this is what we accomplished. We created a cloud that is scalable, that has now 2 availability zones, but we can extend that. It has now 1 region, but we can easily extend that as well. And we have the foundation to grow. We created, for example, a large backbone network-wise. We have all the replication done. Everything is redundant, so we have a solid core to go forward with. So are there questions? Yes?
Is the general focus of CloudVPS only providing VPS, or are you also going to evolve into providing more services like the competitors?
Well, on top of the OpenStack environment, we're also helping our customers to grow into an HA setup. So grow from a single instance to a setup with high available load balancers, multiple web servers, redundant storage. So that's also what we're working on, yes. Yes.
So you mentioned that 75% do not use HA. Are you educating the customers as well for doing this, or did you come up with a solution between availability zones just to have a click and some form of ghost images? Or when you say HA, is it more to load balance between the availability zone and the customer has to set it up?
Yeah, well, that's we basically are trying to educate them to build a load balancer in both regions and have it high available and able to fail over to the other availability zone, and then have 2 sets of web servers on each zone. So we're trying to educate them, and we're also building those clusters for them if they want us to. But what we see is that not everyone is doing that. So some, most are just spawning an instance and installing, for example, direct admin or all dedicated software, and then clicking around, and then when a compute node fails, which sometimes happens, then they are unavailable. So.
But they auto start though somewhere else if a compute node dies, or do you manually move them?
That's now in the new platform. We automatically restart them on a different node. Yeah. So if a compute node fails, the instance is restored. Yes.
Do you offer any guarantees to your customers' branch offices on network performance?
Well, we offer as part of an SLA setup, we offer uptime guarantee. We also have our standard uptime guarantee. Yeah, I'm not sure. Yes. Yes, we have several backup products. We have a backup to our object store, for example, with scripts for that. We also have a more traditional FTP backup solution. But you could also make snapshots, images, and clones of your instances within OpenStack. It is it's a bit of both. We offer the script. We also install the script, but monitoring the script is responsibility of the customer. Any other questions?
What is the current version of OpenStack you're using?
We're currently using the Mitaka release, and that is because we stay close to Mirantis. So that is the release that Mirantis is currently offering. Any other questions? Okay. Thanks then.